Okay, this problem says a 60 kg skier with an initial speed of 20 meters per second goes up a 2.5 meter high rise as shown. 2.5 meters high rise. I wouldn't call that a high rise. Anyway, so as shown. Find her final speed at the top, given that the coefficient of friction between her skis and the snow is 0.8 meters. 0.8. Okay. All right. So, right. Let me do something here first. This is so. Here's just the slope. Okay. What we'll have to do is we'll have to put her on the slope. There's her weight. There's theta. By the way, this is 2.5 meters, and we'll have to find this distance d. So sine theta. Okay, sorry, sine 35. I'm doing several things, so stop me if you don't understand. 2.5 divided by d, and d is 2.5 divided by sine 35. And then we also have to find the friction force on her. Okay, friction force is mu k times the normal force, which is mu k times mg cosine theta. Which is 0.8 times 60 kgs. Notice I will write units when I have space, and if I don't have space, I won't write units. In general, it's a good habit to write units, write all your units down. Okay, so the friction force on the skier is 385.3 newtons. All right, we've just set up the problem. So here is the kinetic energy initial. Here is the kinetic energy final. We'll use the work energy theorem. Net work done is equal to final kinetic energy minus initial kinetic energy. So we are trying to find the final speed. Okay. There are only two forces that do work: gravity and friction. The normal force doesn't do work, and so on. Okay. Is it easy to calculate the work done by gravity? Okay. What is the work done by gravity? Very good. It's the change, negative of the change in potential energy. I knew exactly what you were trying to say. You're a good man, my friend. All right, so what our friend said was minus UG final minus UG initial plus work done by friction is equal to KE final minus KE initial. And so I shouldn't have to draw this at this time, but I will still do it just because patience wants this. So here is the friction force, here is the distance, and that angle is 180 degrees. Work done by friction force is negative FD, and F was 385 newtons, negative 385.3 newtons, and the distance the distance of the slope was, very good, thank you. Okay, so we can calculate the work done by the friction force. Minus 6. Okay. All right, now we're ready to put stuff in. Okay. So minus mg y final minus mg y initial. Okay, so what we'll do is we can be smart about it. We'll say we're measuring the y coordinate from there, from ground level. Okay, so y initial will be 0. Minus 680 equal to 1/2 m v final square minus v initial square. Initial speed was 12 meters per second. Okay, now you see, well, we'll put in the mass 60 kgs. So now you see in this equation everything is known but v final. So minus 60 into 9.8 into y final is 2.5 meters minus 1680 equal to 30 times v final square minus 12 square. Okay, so let me and so v final square is 144 minus 105, that's 3439. All right. So the skier that's going at 12 meters per second, the slope is roughly equal to where that red thing is. You climb up that high a slope, the friction is quite large, the friction coefficient is quite large, and she slowed down to half her speed. Okay? So gravity was slowing her down, and friction was slowing her down. Yep.
Back at the first slide where we were working on the initial parts of the problem.
Okay, let me save this because this thing is a little finicky.